All right, let's get started here on the section 3.3.1 study guide. So there's a couple words here we need to go over before we get started on practicing. And we've been working with polynomials. Today we're going to be focusing on binomials or polynomials with just two terms. We have been adding and subtracting polynomials. Now we're going to be multiplying them. So FOIL, this is a method for multiplying binomials or all polynomials. There can also be more than two terms. And you may have seen this method in middle school, FOIL, where the F stands for the first term, outer term, inner term, and last. So we're going to be using this method as one of the methods of multiplying. Also with the distributive property is the rule. As you know, it means to multiply. It's the rule if A, B, and C are numbers or expressions, then A times B plus C will yield these first two terms, A times B, plus the second two terms, A times C. So this is the general rule of distribution. So we're going to be using this as well when we're multiplying these. All right, let's go look at some practice. What is the shape of a city park skate park? We would say maybe that it is square or rectangular. And then what is the problem asking you to solve? How can you determine the size of a new skate park? All right, so let's go fill in the blanks here on distribution. So you can use the distributive property to multiply two binomials. So again, this whole A times B plus A times C is our general rule of distribution. So let's go practice. Use the distributive property to find this product. So here you have two binomials because there are two terms in each. And we're going to be multiplying them. So A is X plus 3. That's your full term of A. And then we're going to be multiplying it times B plus C. So 2x squared and then positive 4. So here I go multiplying A times B plus C. So the x plus 3 first has to multiply by the first term. So up here we're going to write x plus 3 times 2x squared plus 4. This is your A times B plus C. All right, so first we're going to do the 2x squared times the x. That's this x times the 2x squared. And that's going to give us 2x to the third. And then we're going to do the x times 4. I'm sorry, we just did this times this. Now we're going to do the 3 times 2x squared. So we're going to get 3 times 2x squared. And that gives us 6x squared. 3 times 2 is 6. X squared at the back. Now let's do the x plus 3 times the 4. So 4 times x gives us 4x, and 4 times 3 gives us 12. Now we're going to combine the two, any similar products here, and there are no similar or like terms to combine, so we just list everything out from greatest to smallest. based on their exponent. So we go 2x to the third plus 6x squared plus 4x plus 12. And this entire thing is my result of multiplying the two binomials. So just to give you an idea of like what things we were multiplying, but we're going to get into a regular routine over this. Now we can use the FOIL method, here comes the regular routine, to multiply two binomials. And those letters stand for first, outer, inner, and last. First, outer, inner, and last. The FOIL method helps you remember how to multiply each term in one binomial by each term in the other binomial. Write first, outer, inner, last in each blank. So it's going to be the first times the first term, or A times C. And then you go to outer, which is the A times the D. And then you go to the inner two, which is the B times the C. And then you go to the last two, which is the B times the D. So using the FOIL method to find each product, here I go. First times first is going to be 4 times 3x squared. And that's going to give me 12x squared. Outer is 4 times 4, which is 16. Inner, which is negative 5x times 3, which is negative 5x times 3x squared. That's going to give me negative 15x to the third, negative 15x to the third. And then last is going to be negative 5x times 4, which is negative 20x. Let me rewrite that so it's nice and clear. When I rewrite this, I'm going to put this in order from least to greatest based on exponents. This is called standard form of a polynomial. So the negative 15x to the third will go first. The 12x squared goes next. The minus 20x goes third. And the plus 16 goes last. I just put this in order after foiling. What do you know about the dimensions of the updated skate park? It will be 4 meters shorter in one direction and 9 meters longer in the other. It will be 4 meters shorter in one direction and 9 meters longer in the other. If X represents each side of the current skate park, label the dimensions on each side of the skate park. So if we're talking about a square being X by X, and the area of that square being X squared, we're now going to draw out the skate park and on one side we have the X plus 9 and on the other side we have the X minus 4, kind of like a length and a width. So how do we know that? If it's 4 meters shorter in one direction, here's my X minus 4, and 9 meters longer in the other. And that's longer than the original X and shorter than the original X. So that's where the X comes from. So this one over here is the current skate park's dimensions, and this is going to be the updated skate park dimensions. And in comparison to the original dimensions, this would have been extended out a little bit down here, and then this one's going to be extended out here. So this one's shorter than the original. The original was way down here, and this one's longer than the original. All right, so let's use the distributive property. So by the way, if you kind of peek at the next page, there it is drawn out for you. So here's my x plus 9. It's been extended from the original x. And then here's my x minus 4. It's been shortened from the original. So awesome. This right here is my new skate park area. All right, use the distributed property to find the product that represents this area. So my A is going to be x minus 4, the entire first binomial. My B is x, and my C is 9. So A times B plus C is going to yield A times B plus A times C. So here I go. Let's start with x times x and x times negative 4. And then 9 times x and then negative 4 times 9. So I did all of these pieces. And then we can combine the two middle terms. Negative 4x plus 9x is 5x. If the current skate park is 25 by 25, then what is the area? And so current skate park means that just 25 by 25, length times width, or x times x, gives us 625 meters squared. How does the area of the new skate park compare if x equals 25? And so we're going to go ahead and plug into this x squared plus 5x minus 36. We're plugging in the new 25. And so 25 squared is 625. 5 times 25. And then I'm going to grab a calculator and add that all up. 625 plus 125 minus 36. And I get 714 meters squared when I add that all up. Okay, let's go ahead and flip. Label each part of the tile model and write factor or product on each line. So up here, this x plus additional 3, this is one of my factors. And over here, this has an x times an x, and then plus 1. This is also a factor. Sorry, I was supposed to write factor up here, not x plus 3. And then over here, what this all multiplies out to, that's my product. All right, and it's my factor times my factor, which equals the product. So what are those two factors? Again, we did already get the x plus 3 on the top one. And so down here, I've got an x and a 1. So that one is 2 x's plus 1. And then the product of that would be from foiling. So I'm going to go first times first, or 2x times x, outer times outer, or 2x times 3, inner times inner, 1 times x, and 1 times 3. Last. Let's combine that all together. 2x squared plus 6x plus 1x plus 3. Combine the middle terms, and there is my product. All done. All right, let's go look at this last fill in the chart. Here it's wanting you to do FOIL on these special cases. So I go first times first, or x squared. Outer times outer, or negative 2 times x. Inner, inner, last. Combining those middle terms, do you notice that the negative 2x and the 2x zero out? This is called the difference of perfect squares. Because x squared is a perfect square and 4 is a perfect square, and minus means the difference. So when these two middle terms zero out, because there's a plus and a minus with the same numbers, that's called the difference of two squares, difference of perfect squares. All right, let's look at this next one. This one is perfect squares. Two of the exact same thing. Let's see what happens on this one. If I stretch this out to x plus 3 times x plus 3, and I go first times first, x squared, outer times outer, 3x, inner, inner, another 3x, and last, last, and I combine this together, notice I get a double middle term, which yields this, 6. So what do I do for this one? This one's called the perfect squares, and I recognize that since it's the same number, I am doubling that middle term. Finally, this is another perfect square. Because it's the same thing twice, x minus 3, I'm stretching it out. First times first, outer times outer, inner times inner, last times last. Inner, inner. Notice the double middle term. Notice that when the perfect square has a minus in it, then the doubled middle term has a minus. Notice that the perfect square, when it had a plus in the middle, that the double middle term also had a plus in the middle. And that yields my perfect square double middle term.